All right, so hello again from my screen. We are going to be revising for loops today, and we're going to be talking about a different kind of loop that's very, very useful as well, called the while loop. If we have enough time today, since we're going to be solving a lot of questions. So I just wanted to start with a couple of examples. And if you remember, for loops, basically, they're very, very useful. They help us iterate or repeat specific instructions and execute things more than once and execute different instructions more than once in a very, very easy and efficient way. So if you remember, for loop consists of three different components. We have the counter, which is, I usually like to call it integer I, because we are going to be using it as an index later on when we introduce different topics like arrays. But for now, we're going to go with integer I, and I'm going to give it an initial value of 1, for example. And also, one thing about the counter is that you can also simply rename it outside of the for loop and just remove integer, but I always prefer to declare it and initialize it inside the for loop, although it really doesn't matter. And then we are going to be using, and the second component is basically the, let's say the condition or the range. It helps us, or at least it helps the compiler know that we want it to stop at a specific number or we want it to stop at a specific value. So for example, last time we discussed printing out numbers from 1 to 10 or from 1 to 5 or from 1 to 100. And we said we gave the variable I an initial value of 1, and then we set the range to less than or equal to 100, for example. I'm just going to go with 10 because 100 is a lot. And the last component is the iteration, which is basically how we're going to be repeating the for loop. And I++ is the same as I equals I plus 1, and it's the same as I plus equals 1. So there are so many different ways to declare the iteration. But I always like it. I++ to me seems like it's the most convenient way to set the iteration. So I want you guys to help me now create, or at least create a program and write a program that finds the sum of numbers from 1 to 5, for example. Let's go with 5 first. I'm going to start with the first step, and I'm going to declare a new variable called sum, and I'm going to give it the initial value of 0. And I want you guys to help me find the sum of numbers from 1 to 5 through this for loop. What do you think?
We write inside sum equal to I plus sum.
Absolutely. So sum equals I plus sum, 100%. And there are so many different ways to write this as well. I also prefer to write sum plus equals I. It's more convenient, but they're all the same exact instruction. It's just I like to find these shortcuts and use the assignment operators. So this is perfect. This is exactly what we're doing. And I set an initial value of 0 because as the for loop runs, the first instruction is going to be 0 equals 0 plus 1, right? Since I, or let's say 1 plus 0, just to avoid confusion, since I plus sum, it's in that order. So I is 1, it starts from 1, and sum is 0. So the first value is going to be 0. Now, mathematically, of course, 0 does not equal to 1, but 0 here is a variable. It's not just 0, which is sum. So this is how it goes. This is the first instruction, and then later on, it's going to be sum equals 1 plus 2, and then 1 plus 2 plus 3, and so on and so forth until we get to 5. And what if I want to show this value, or what if I want to actually see out this value to the user? Where do I show the user? Where do I insert that instruction? Do I insert it inside the for loop or outside the for loop? If I want to print out sum. What do you think?
Outside.
Outside, yes, absolutely. Because if we actually see out the sum inside the for loop, and end line is not very significant here, we can have it or not. It's going to keep on printing the sum every time. It's going to keep on printing the value of the sum 5 times, and that's not what we want. We just want the sum from numbers 1 to 5 and nothing more. So this is perfect. This is just a quick revision, and I want us to solve another question to freshen up. So let's assume we are university professors and we want to write a program that helps us find the average of the GPA of students, for example. So I am going to remove this, and I want you girls to help me write this program from scratch. So I want to insert, for example, 5 grades for 5 different students and find the average of all these grades. So what do you think the first step would be?
I think we should declare a sum and an average.
Absolutely, yes.
Sorry, yes.
We need to.
So let's declare sum, for example, and initialize it at 0. And Zaha also said initially declare an average, but we also need to declare something else, right? What do you think we should declare? How are we going to be getting the information from the user? We need to store it somewhere, right?
So basically an integer that we will ask the user to enter.
Exactly. So integer grade, for example. Also, these do not need to be integers. Like, let's try to change things up and go with float, because we've been using integer all this time. Let's try float, and we can try double as well, since double is even bigger. So that's perfect. We're done with the first step. So what would be the next step? How would we find the average? What would be the next step? And keep in mind, we're finding the average for 5 grades. We're specifying the number of grades.
I think we should start with CN grade.
So we are going to be, that's a great step, but we are going to be we're going to be writing a program that will see in the grade 5 times. So, and we only have 1 grade variable. So what would help us receive the information 5 times instead of writing CN and declaring grade 5 times? What do you think? We can use something.
A loop?
Absolutely. So we can use a for loop. Let's start with for, since we have not started with while. And how do I construct my for loop? Yeah, so how do I construct my for loop? I'm going to start with the first step. I'm going to start with integer y.
So then integer is going to be equal to 5, I think, because we said it's equal to 5. We have 5 grades.
So we want the user to enter it 5 times. Is it going to be equal to 5? What do you think?
Smaller than or equal to 5.
Yeah, exactly. Less than or equal to 5. Absolutely. And the increment is I++. We're increasing I once every time. We're increasing the counter once every time. And now, how do we exactly receive the grade? I think now we should be receiving the grade from the user, right? So we include CN grade inside of the for loop, since we are going to be receiving grade 5 times for 5 different students. And then we have another step that we talked about a couple of minutes ago. What do you think? How do we find the sum? So sum, as we mentioned before, is basically sum plus, what's the variable over here? What do you think? What are we adding?
The grade.
Yes, exactly. We're adding the grade, right? And as I mentioned, we can just say sum plus equal grade. It's the same exact thing. So when we exit the for loop, now this for loop simply receives the grade 5 times. And whenever the user or whenever the professor, let's assume, gives the program or gives the compiler the grade, provides the compiler with a grade, it would add it to the sum. I'm sorry, I didn't get that. It's okay. So who can help me figure out a way to find the average of these 5 grades? So we declared the average above. How can we find the average and print it out?
The average is basically the sum over the number of like what we want, or so basically it's gonna be over 5.
Yes, 100%. So average is simply going to be sum divided by 5, right? Perfect. And all we have to do is see out the average is average. And that's as simple as it can be. Also, we can actually disregard average and let's comment it out. And although I usually prefer we always store our values in a specific variable, and we can replace average with sum divided by 5. But as I mentioned, I always prefer we store our variables, or we store our values in a variable. So this is perfect. So we just had a quick little revision for for loops. For loops are very, very useful. They simply ease the process for the user. And instead of having the user see out or see in hundreds and thousands of lines, we can just simply use a for loop that would help us with that. So let's move on to something a little more difficult. It's actually very, very similar to the idea of a sum, but we are gonna go and try to solve in search of an easy problem on Codeforces. Now, I hope all of you girls have Codeforces accounts, since I will be sending you questions throughout the course for Codeforces. But for now, let's just start with in search of an easy question, and let's read it together. So, when preparing a tournament, Codeforces coordinators try their best to make the first problem as easy as possible. The coordinator had chosen some problem and asked N people about their opinions. Each person answered whether this problem is easy or hard. If at least one of these N people has answered that the problem is hard, then the coordinator decides to change the problem. For the given responses, check if the problem is easy enough. All right? So the question is asking us for 2 different inputs. The first line will contain a single integer n, as you can see here in our first test case. And the n is the number of people who were asked to give their opinions. All right? And the second line contains n integers. Each integer is either 0 or 1. If the ith integer is 0, then the ith person thinks that the problem is easy. And if it's 1, then the ith person thinks that the problem is hard. So let's check the test cases. So the first test case, there were 3 people were asked. The first person said that the problem was easy, since 0 stands for easy. The first person said it was easy. The second person said it was easy, but the third person said that the problem was hard. All right, and if we focus on this line over here, if there's at least one person who thinks that the problem is hard, then the result or the output will be hard. However, in the second test case, we only have one person. We only asked for one person's opinion, and they said that the problem was easy. So the problem, we see out, or we tell the user that the problem is easy. So this is a little different, but I'm pretty sure you girls can easily get it. So what do you think the first step would be to solving such a problem? What do you think?
We need to declare the integer n.
We need to declare the integer n, absolutely. So I'm actually going to be using a different compiler. I'm going to be using ID1. I think you remember we used ID1 before. Do you remember when we said that ID1 is actually, it eases the process for the user to input specific input. And I just want us to get used to different compilers. We can absolutely use GDB as well, but I just want us to try a different compiler and try ID1. So the thing about ID1 is that we can just simply copy this input in order for us to test it out. So Yasmin was the one to tell me that we have to declare integer n, right?
Yes.
Okay, awesome. So after integer n, what do we need to do? What would be the next step?
The for loop.
So yes, the for loop. But before the for loop, what do you think we need to ask the user to do before the for loop?
The 0 and 1 for if it's easy or hard.
So yeah, we're going to be working on that. We're going to be working on that in the for loop. But in order for us to declare the range of the for loop, we're going to have to ask the user for n, right? So 3 here is n, and we get that from the user. So we have to cn n, and now we actually start constructing our for loop. So how do we construct our for loop? What should we include within our for loop? I'm going to start with integer I, and I'm going to give it the value of 1. So what do you think the range, what do you think the condition should be?
I is less than or equal to n.
Absolutely, 100%. And we're going to set the increment as I plus plus. Awesome. So let's go back to the question. We have the user will enter n, and in this test case, n is 3. And we have 3 people that were asked to tell us whether the question was easy or hard. 0 stands for easy and 1 stands for hard. And if we have 1 hard answer, then the question is automatically hard. So how do you think we will establish whether a question is easy or hard? This is a tricky one. What do you think?
I think that first we should ask the user to input whether it's 0 or 1, and then we can use an if statement.
Absolutely. So we have to include another variable, right? Ask the user to add, like we always store our values in variables. So we have to include integer, let's for example say choice, or you can absolutely name it anything you want. And we ask the user to enter choice. Okay, but here's the thing. The first one is 0, and the second one is 0, and the third one is 1. What if the first one was 1, and the second one was 1, and the third one was 1? There's something about 1. There's something about having to program a specific thing or having to include another variable that helps us track whether whether at least one person said that the question is hard. And it's called a counter. Now, in these types of questions, we need something called a counter. And a counter is basically a variable that helps us count any value we want to count. So for example, I'm just going to give you a very random example. I want to write a program that finds even numbers, or like that counts even numbers from 1 to 10. All right. Basically, what the program does is we have to, of course, include an if statement. And we say that if this number mod 2 equals 0, then we have to increase the counter by 1. All right, so the counter here acts as a variable that determines whether we have a 1 or not. I know this is a different concept, but I'm going to try to explain it as best as I can. So we are going to include another variable called counter. And we have this instruction ready. We are going to ask the user to enter choice. And if choice equals 1, and we have to increase the counter by 1. Does that make sense? And then we're going to be benefiting from this later on. So in order for us to determine whether one person or more has said that the problem is hard, we're going to be using, all right? And we're going to be using the counter later on to print out whether it was easy or hard. So didn't we say that 1 is hard? And if we at least have one hard answer, or like one answer in the second line of input, then the program is then the question is automatically hard. So basically, the counter, I inserted the counter just to ease the process for us and to track the answers. I know this is a new concept, but does it make sense?
Yes.
Yeah, does it make sense? Okay, awesome. So all we did was include another variable that tracks if we have one or not. And if we at least have one hard answer, like one person saying that it's hard, then we have to print out hard. So what do you think we should include after the for loop?
If counter is greater than or equal to 1.
Greater than or equal to 1, absolutely.
Cout. Hard.
100% hard. And if it wasn't?
Else cout easy.
Absolutely. And we can just simply say, but this is 100% correct. We can just simply say if counter is greater than 0, right? But we can just keep it as greater than or equal to 1. That's totally fine. So this is basically how we answer the question. All we did is declare integer n, which helps us set the range, which is basically the number of people we asked. And then we include the choice. Before declaring choice, we ask the user to enter n, and we see in choice in the for loop n times. And we use the counter simply just to count the times a person has said that the question was hard. Are there any questions so far before we test the code? Okay, so let's try and test our code. This is supposed to give us the answer. This is supposed to give us hard, right? Awesome. So let's try to submit our code and see how it goes. So all we have to do is copy, and we go to code forces. We simply click submit code, and we choose the answer we want to submit. In this case, it's in search of an easy problem. And we paste our code. All right. So let's try to submit our code and see what code forces gives us. I actually wanted us to test the second test case, but let's see if the answer is accepted or not. Sometimes it takes a little bit of time. Let's see. It's taking a lot more time than usual, but that's fine. Anyway, so all we did was simply create a counter that, here we go. So our problem was accepted, our solution was accepted. So basically all we did was declare integer n, ask integer n from the user, and keep on asking for the choice. And if at least, if the counter is greater than 0 or greater than or equal to 1, which is totally fine, then the problem would be hard. Other than that, the problem would be easy. All right, so I wanted us to solve one more question before we move on to a completely, well, maybe not completely different, but to a different topic. So this is a slightly trickier question, but I really want us to solve it because it's really, really fun. And it is called Hulk. All right, so let's read it together. So Dr. Bruce Banner hates his enemies. As we all know, he can barely talk when he turns into the Incredible Hulk. That's why he asked you to help him express his feelings. Hulk likes the Inception so much, and like that his feelings are complicated. They have n layers. The first layer is hate, second one is love, third one is hate, and so on. All right, so for example, if n equals 1, then his feeling is I hate it. And if n equals 2, then his feeling is I hate that I love it. And if n equals 3, I hate that I love that I hate it, and so on and so forth. All right, so here, these are the test cases. They're mentioned above. If it's 1, I hate it. If it's 2, I hate that I love it. And if it's 3, I hate that I love that I hate it. So what do you think the pattern here is in that question? It's a tricky question. But what do you think the pattern here is? There's a specific pattern. What do you think? So the first one, Hulk's feeling is I hate it. And the second one, when we input 2, I hate that I love it. And 3, I hate that I love that I hate it. It has to do with the number. It has to do with n. What do you think?
If n is an odd number, it ends with I hate it. If it is an even number, it ends with I love it.
Absolutely, 100%. That's exactly how it is. So if it's an odd number, the feeling ends with I hate it. But if it's an even number, it ends with I love it. Okay, are you ready to start the code? Let's start printing out the code. Okay? So there's only one line of input, which is integer n. And we're gonna see an n, that's the easy part. And then I am gonna follow your lead. I want you girls to help me write the whole entire code. What do you think?
Okay, we start with 4 integer is equal to 1.
Okay, 4 integer I is equals to 1. Oh, sorry. What next?
And I
is
is
less than
equal to or less than n.
Less than or equal to n, 100%.
And then I plus plus.
Absolutely. So what do you think? This is the tricky part. What do you think? So we said that if the number is even, it would print I love. And if it's odd, it would print I hate. What do you think?
But there's something in the code that, let's say if they said 1, I hate it, and then 2, I hate that I love it. So like, it's like they're adding what's before.
Exactly, 100%. And that's something we need to figure out now. So we have to figure out how we include that, and how we include I hate, and how we include I love, and how we include it. We have to figure that out together. But let's start with baby steps. So what's our first step? What did we say about even and odd numbers? What did we say about the pattern?
If n,
If n?
I think if I.
Yes. So why do you think it's I?
Because in the for loop, like
Okay.
when I is 1, I should put I hate it, and then when I is 2, it's like we're counting I.
So yes, so we're determining basically whether I is odd or whether I is even. So if I is odd, it has to print I hate. And if I is even, it has to print I love. Does that make sense?
Yes.
Exactly. So what do you think we should do now?
So if I modulo 2 equals
Yes.
0.
100%.
See out. I love it. I don't know what the
I
phrase
love
is.
it.
Yeah.
Okay, so How many times do we repeat it? What do you think? How many times do we repeat it?
1 time.
1 time, right? So do we have to include it here again?
No.
No. Yes. Okay. And then what next?
Okay, else, see out,
Mhm.
I hate.
See out, I hate. Awesome. Okay. So what about that? What do you think? That is a tricky one. Over
That
here.
is only not seen when it is 1.
It's not seen when it's 1. Okay.
I'm-
Yeah. That I totally understand what you're talking about. And that's very, very valid. So how do you think we should express that in our code? So I'm going to see out that for now. Okay, I'm just going to see out that and see how it goes. Okay, and then we're going to figure out how we can fix it. And where do we put it since we repeat it once in the code? Where do you think we should include it?
Outside the for loop.
Absolutely outside the for loop. Okay, so do you want to give it a shot? Do you want to try to run the code and see how we're doing? Let's try
Yes.
with 1. Yeah, let's try with 1. Let's try easy. Oh, oops, that's my bad. I think I forgot the semicolon somewhere. Yep. Sorry about it. So there we go. It gave us a compilation error. We fixed it. Okay. I hate that it. So is that the right answer? Is I hate that it the right answer?
No, that is added to it.
That is added to it, exactly. So what do you think we should, how do you think we should restrict that?
If I is less than n,
100%, absolutely, excellent. If I is less than n, right? Because when I equals n, we do not want it to print that. So here I hate, I equals 1. That I love, I equals 2. That I hate, I equals 3. And n equals 3. So we do not want it to print that when I is equal to n. 100%, that's excellent, Yasmin. So do you think we should try our code again and see what it gives us? Let's run a code and see. I hate it. Perfect. So let's try something else. Let's try 3 and see what the code gives us. I hate that I love that I hate it. You want to try something big? Let's try 7. Just for fun. But our code is working. So I hate that I love that I hate that I love. And because 7 is an odd number, it ends with I hate it, right? Since this is the pattern. Excellent. Honestly, girls, you're absolutely amazing. I did not expect us to solve it that fast. So that's great. Let's try to submit our code. But before we submit our code, are there any questions? Because this is a slightly tricky question. This is a little trickier than the ones we've tried before. Are there any questions? Okay, so we're good, I'm assuming. Let's try to submit our code. It's the same process. We click submit. We choose the problem we want to submit. And we submit and we see what Code Forces hopefully gives us. Let's see. Accepted. So our code is accepted. Girls, you're absolutely amazing. That was excellent. I genuinely did not expect us to solve it that fast. So I think it's time to move on to a different type or different kind of loop. And I think we have enough time to explain it, try a couple of questions, and perhaps try out a different exercise. So we talked about for loops, and we talked about how for loops are very, very useful, and they're very efficient, and they help the programmer in so many different ways and for so many different projects and for so many different oh my god, I forgot the word. Anyway, for loops are very, very important, and they help us with efficiency, and they help ease the process for the programmer. But there's another type of code, there's another type of for loop called the while loop. So basically a for loop, to me, I see a for loop as a more compact while loop. And a while loop is just simply while, open and close brackets, and curly brackets. Now, the thing about while is that it can be used for so many different things, and it can be used for many different things that would help us. And there are, I mean, for is very, very important, but while is also important. It can help us with things that wouldn't be so easily achieved with a for loop. But the thing about while is that it's all over the place. So it's not like for loops. For loops are basically more compact. You include the counter, you include the condition, which helps us set the range for the for loop, and then you include the increment. But in while loops, you have to separate these things. So I'm going to start with integer index, and I'm going to give it a initial value of 1. Okay? I want the while loop to help me print numbers from 1 to 10. So we did that with for loops, and I want to try it now with a while loop. The thing about while loops is that you can only include one thing here. I mean, well, technically not one thing, but you can only include a condition. You do not initialize any variables. You do not increment or decrement. You do not set the iteration here. All you have to do is put the condition in these 2 brackets. So in order for me to print numbers from 1 to 5, I will set the condition as index is less than or equal to 5. All right? And all I have to do is simply cout index. And there's one more thing that I need to do. Can someone help me with that? There's one more thing that we missed here.
Index plus plus.
Index plus plus, absolutely. So that's, sometimes I even tend to forget it. Sometimes I forget the increment or the iteration in while loops. So it's always important to remember to have your counter, which here we initialized as indexed, and we gave it an initial value of 1. And then we set our condition where index is less than or equal to 1, and we cout index. And I'm going to actually add the line just so each and every number is printed on a different line. And we basically increase the index 1 every time. So let's see what the program gives us. There you have it. Prints 1, 2, 3, 4, 5. It prints numbers from 1 to 5. So how do you think I can print even numbers from 0 to 10 using a while loop? What do you think? How do you think I can do that? I want to print even numbers from 0 to 10.
Okay, so index is 0. So and index less than or equal to 10.
Okay.
And then inside the while loop, we put an if statement. If index modulo 2 equals 0, then we cout even.
Even, okay, sure.
Else cout odd.
Else cout odd, absolutely. So
And
do you
then
remember we
index
even, yes, else cout odd. And we never forget our increment. So I'm just going to remove this for now. Absolutely. So we're going to run this and see what it gives us. So it's gonna say even odd, even odd, even odd, even odd. Absolutely. So do you remember we talked about a shortcut when it comes to even and odd numbers? When I didn't specify anything, I just specified for you as a programmer to print even numbers. Do you remember we talked about a small little shortcut? I'm gonna remove this and I want you to help me with that shortcut. What do you think?
Lahza, you wanted to print only the even numbers?
Yes, but that's totally fine.
Okay, I'm sorry. I thought you wanted to say.
Okay.
Okay.
It's okay. Absolutely. No, this is great. But this is basically the same concept. But who can help me with the shortcut? I just want to print even numbers, but using a while loop this time. What do you think? I'm going to give you a hint. It has something to do with the index and the iteration. I'm going to see out. I'm going to start with, I'm going to give you a big hint. I'm going to see out index. But there's something I need to fix. One small thing I need to fix. What do you think? How can I print even numbers? Girls, we talked about this before. It has to do with the iteration. It has to do with the increment. I only want to print even numbers from 0 to 10. How do I do that? And I do not want to use if statements. This is the challenge here. I don't want to use if statements.
+2.
Yeah, plus equals 2, right?
Yeah.
Because it's going to print 0, 2, 4, 6, 8, 10. So that's how we print, because since I'm only asking you to print it, this is exactly how we do it. It's a quick shortcut. 0, 2, 4, 6, 8, and 10. So what about odd numbers? It's a quick fix. Quick fix. What do you think?
Do you want to start from 0 or from 1?
So is 0 considered an odd number?
No.
No. So where would you like us to start?
1.
1, right? Yeah, awesome. So we are going to start with 1 and see what it gives us. Awesome. 1, 3, 5, 7, and 9. So these are very simple examples. You can use while loops for so many different things and for so many more complex things. But for now, we are going to stick with easy examples until we get the hang of it, and we get the hang of it a lot better. And then we can get to some more difficult examples and more challenging. And to me, I feel I would like to call them more fun examples. So let's try something else. Let me give you a different example. I want us to print hello world, for example, 5 times. What do you think I should do inside the while loop? I want to print hello world 5 times. And I want different voices. I want to hear from different people. How can I print hello world 5 times? Come on, girls, you can do it. You can definitely do it. I'm going to give you a hint. Go with 5. Just one small thing left.
See out and then hello world. But anyway, hello world.
100%. Thank you, Farah. Perfect.
Right,
So that's so that's basically how it is. We set the index as 1. We set the condition as index is less than or equal to 5 because we want to print hello world 5 times. And we're going to run our code and see what our code gives us. Hello world. Oh, so it printed it more than once. Printed it 5 times. Maybe it got stuck on 10. I'm not sure. But that's fine. Let's try again. Let's try 4, for example. Oh, There you go. I think the compiler kind of crashed. I'm going to try to copy this and go on a different tab. Sometimes that happens, and that's fine. Sorry, 1 second. It sometimes happens, it sometimes crashes, but that's fine. So we're gonna be, it's supposed to give us hello world 5 times and not 10. So let's see. Interesting. It's fine. Oh my God. Can someone tell me the mistake? There's one mistake that I did. What do you think? It keeps on going and going and going. It's an infinite while loop. There's something we forgot. What do you think it is?
Index plus plus.
Exactly. We forgot index plus plus. And I blame the compiler. I should have blamed myself. So it's going, it's an infinite while loop. See, even sometimes, and I've been practicing coding for like 2 to 3 years, and I sometimes forget these things. So that's basically what happened. It went on an infinite while loop because I forgot the iteration. Now, and I'm sure it's supposed to print a hello world 5 times, and there you have it. So perfect. This is basically how while loops work. Now, the thing about while loops is that there's another type of while loops called do while, which basically executes, or let's say checks the code first and then checks the condition. I mean, everything you can do with the do while, you can do with the while loop. So I wouldn't say they are very, very necessary, but it's sometimes you do need to use do while loops for specific things. So for example, in order for me to create a do while loop, I am going to erase that and set the index as 6, for example. I'm gonna, or 7 or 6 or anything. And all I have to do is include do and then 2 curly brackets and see out the index. For example, I want to print the index, an end line, an index plus plus, for example. And then I create a while loop that basically checks the condition. In this case, even though index is 6 and index is not, and 6 is not less than or equal to 5, it's still going to execute this block of code and then check the instruction. So basically, this is what do while is all about. It checks the code first, and it executes the code, and then it basically checks the condition in the while loop. So here, if we had just a typical while loop, it really shouldn't be doing anything. But since we're using a do while loop, where, as I mentioned, the do while checks this, or let's say executes the block of code before checking the condition, it is going to print 6, but then it's not going to be doing anything because 6 is not less than or equal to 5. I mean, I personally do not use do while loops that often, because as I mentioned, everything you can do with a do while loop, you can do with a while loop, but there are certain exceptions where you can use a do while loop, or where you actually might need to use a do while loop. But for now, we're just going to be focusing on for loops and while loops. And we're going to actually start with a small little project. I do not think we have enough time to solve the code forces questions I had planned for today, but that's totally fine. We're just going to do the project and go on with the project until the rest of the session. So I want us to create a guessing game using while loops. Okay? So in order for us to create a guessing game, I want to initialize or declare a variable called number, and I want to give number an initial value of 7. And in this guessing game, the user will keep on trying to guess the number that I have here, that I initially declared before. So I'm going to include another integer called guess, for example. And I'm going to use a while loop to create that game. So again, basically our guessing game, we have declared an initial number, which is 7 in this case. It can be absolutely any number you want. I just chose 7. And we're going to ask the user to keep on trying to guess what this predetermined number is. All right? So here in our condition, in order for us to keep on going, and in order for the compiler to execute the while loop, there has to be a specific condition over here that sets, or let's say that sets the guessing game, or that actually helps us execute the guessing game. And I'm going to keep it here for now. We're gonna be talking about it in a bit. So here's how the guessing game works. I will see out, enter a number. I will prompt the user to enter a number. And the user will enter guess. Okay? So if the user entered any number other than 7, the while loop will keep on going and going and going until the user guesses 7, in which the compiler, or basically the code, will leave the while loop, and we will tell the user that they won. Okay, does that make any sense? It's a very, very simple game. The game is just a while loop, a single while loop, and the condition we will be determining right now. And all I'm doing is asking the user to enter a number, not a name. And the user will enter guess, and they will keep on entering number. They will keep on entering their guess until they get it right, in where they will leave the while loop, and a you win message will appear. So in order for us to do this, what do you think the condition in the while loop should be?
Guess not equal to 7.
So guess not equal to 7, that's true, but where did we store 7?
A number.
Exactly. Perfect. So as long as guess does not equal number, then keep on prompting the user to enter a number and enter a number and enter a number and enter their guess until guess is correct, and where the user actually guessed 7, where then they would exit the while loop and a you win string will appear. Okay, does that make sense? You want us to try and run our code and see how it goes? Let's see. Okay, so the compiler is asking us to enter a number. I'm gonna try 4. It's gonna ask us to enter again 2, 8, 6, and I'm gonna try to enter 7. And it's gonna give me a you win message. But I personally do not think that this is fair, because the user can enter so many different numbers and they have so many different chances, because the while loop is gonna keep on going and going and going as long as guess does not equal to number. All right, so let's change things up, and I'm gonna help you out and add a couple of variables that will help us create an even better guessing game. So here, I want us now in this small little project to allow the user to we're only gonna allow the user 3 tries. Okay, so I'm gonna add an extra variable. I'm going to call it limit, for example. And I'm going to say 3. I'm going to give it an initial value of 3, since I'm only to enter the guess 3 times. All right? And in order for me to track that guess and to track how many times the user is guessing, I am also going to add another integer called count. And every time the user enters a number, I'm going to increase the count by 1. And if it reaches 3, then the user will, we are going to tell the user that they unfortunately lost. And the last variable I want to add is a Boolean variable. And I'm going to call it out of guesses. Okay, and I'm going to give it the initial value of false. All right, so a quick synopsis. Basically, I kept the number, which is going to be 7. I'm going to keep it as 7. I'm going to keep our guess, which is entered by the user. However, I added 3 extra variables. The first variable called limit only allows the user to enter the number 3 times and to enter their guess 3 times. And count will help us as programmers really track the number of times the user is entering a specific value. And the last value or the last variable is going to be a Boolean variable called out of guesses, which we will give the initial value of false, since you're not going to enter the game when you're out of guesses. All right? So let's try to construct this program together. Okay? So I am going to help you out and include an if statement. Okay? And I'm going to put this piece of code inside the if statement. All right? So what do you think the condition here should be?
Count less than or equal to limit.
So we're gonna go with, let's go with less than for now. Okay, let's make it harder. Less than limit. Perfect. Okay, awesome. So if count is less than limit, enter a number and see in guess. Okay, and after that, what do we do?
Count plus plus.
100%. Count plus plus. So as I mentioned, count, the only function for count is to help us keep track of the number of guesses, of the number of numbers the user is entering. Okay, so for now we are on a perfect track. All we did is include an if statement. Okay, the condition is if count is less than limit, then enter a number and see and guess and count plus plus. But what if count is not less than limit? What do you think? What do you think would happen if count is not less than limit? I'm gonna help you out.
Out of guesses will be true.
Absolutely. Yasmin, you are on fire today. 100%. It's going to be true, right? So this is why I chose a Boolean function, because it eases the process. So if count is less than limit, meaning the user still has more chances to enter a number, then I will allow the user to enter their guess. However, I will increase the count. However, if the count is equal to the limit or greater than the limit, we will set the Boolean variable as true. Okay, so we're so close. We are so close to finalizing the whole entire project. So there are things that we need to edit. Starting with the condition. Do you think guess does not equal to number is going to be enough? What do you think? Is it enough? It really isn't, right? Because what if guess does not equal to number and we kept it as is? However, they are out of guesses. They're not allowed to enter the while loop again, right? So what do you think we should add in the while loop condition? So if guess does not equal to number, and something else.
And out of guesses equal to false.
Absolutely. Out of guesses equals to false. But do you remember so this is 100% true. We can just keep it as that. But like I always like to follow the shortcuts, and equal to false can simply be replaced with an exclamation mark before the variable. Do you remember when we talked about that before?
Yes.
Yeah, but out of guesses equals false is absolutely true. However, I always like to follow shortcuts. So perfect, absolutely perfect. If guess does not equal to number and you are out of guesses, then I'm sorry, user, but you are not allowed to guess again. And there's one last thing. So if guess does not equal to number and you're out of guesses, you win will always be displayed to the user. However, they're not always going to be a winner. So there's just one last thing we need to do in order for us to finalize our project. What do you think that is? Something over here.
We need to add an if statement.
Absolutely. What should we include?
Out of guesses should be false.
Okay, out of guesses equals false. I'm going to go with equals false for now.
Or the explanation.
Or
mark.
yes, but let's go with this for now because it's absolutely correct as well. So if it was false, what do you think the user should print out?
You win.
You win 100%. And if it wasn't, if they were actually out of guesses, then see
It
out.
would see out, you lose.
Absolutely, perfect. And that's exactly how it is. So here's the thing, I really wanted us to do this project together because this is what programming looks like. Like as a programmer, you're not just going to be writing one single for loop or one single if statement, or you're not just going to be defining a couple of variables and that's it. Like this is what programming is all about. It's about incorporating different functions, incorporating different statements and different things you can use in the language to formulate and create a project or to create a product or to create anything. So this is what programming is all about. It's about connecting all these dots and creating this connection between different functions and different ideas. All right. So before we test our code, are there any questions? Absolutely any questions? Are we all good?
I just wanted to ask one question.
Go for it.
When we declare an integer n, or
Yeah.
grade actually, I mean guess, it will automatically be 0.
So that's a very good question. Here's the thing. If we are requesting the user to enter a guess, then whatever the user entered will be replaced, okay? But in our memory, in the memory of the device or like in the compiler, there are specific spaces that hold up variables. We're not going to go into details, but these spaces sometimes have values that have not been used before, and we call them garbage values. And that's why sometimes we have to initialize certain variables like sum or count. We have to initialize them as 0 just to prevent getting garbage. But for now, since we are requesting the user to enter guess, it's not going to really matter because regardless, since we're asking the user to enter, it's going to replace whatever the user enters into guess. Does that make sense? Does that answer your question?
Yes, but if the number was 0, the whole program, would it work?
If it was 0, if we initialized it as 0?
No, if number was 0.
If not, yeah, absolutely. So here's the thing, number is what we decide. Oh, sorry. Yeah, go for it.
No, yeah, I know, but then guess, okay, the garbage number of guess is 0. And then when we say while guess is not equal to number, but my number is also 0, so they're equal. I don't know.
Okay, now I guess what you're talking about. So if we assume that number equals 0, and yeah, but the garbage values is not something you should be concerned with. I thought it was going to confuse you. That's why I didn't mention it. Didn't mention it before. But like garbage values are something that have to do with the compiler itself. It has nothing to do with us as programmers. Like these garbage values are there. They're unused. They're numbers that we don't use. They're just there to fill up space. All right. So does that make sense? So do not worry too much about that. Because even if we initialize number as 0, guess is not going to be 0 unless we initialize it as so. Does that make sense?
Yes.
Okay, awesome. But don't worry too much about garbage values. Because we want to prevent garbage values, because we want to actually prevent them, we always initialize our variables and we initialize our counters and initialize variables like sum. We initialize them as 0 just to prevent that. But it's not something you need to worry about, okay? So let's start with, so let's actually try to run our code and see how it goes. So the number we're trying to guess is 7. Let's assume we do not know that it's 7. Let's see. So the user, the programmer, the compiler is asking us to enter a number. I'm going to go with 9, 4, and 3. It's supposed to give us you lose because we're only allowed 3 trials, right? So let's try to actually guess the number on the third guess, for example. So let's go with 4, 2, and then 7. You win. Perfect. And so on and so forth. Even if we guess 7 from the first time, I entered 7 by mistake. You win. It took the first 7 that I entered. So this is why conditions are very important. This is why we have to set our conditions in the correct manner. So since 7 equals to number and we are not out of guesses, it's going to exit the for loop and tell us that we won, since out of guesses is false. However, say if we use up the limit and we do not enter the right number, the programmer, as we saw before, will give us you lose. Okay? This is one of the big programs that we've written throughout the course. But this is also very important because, as I mentioned, this is what programming is all about. It's about connecting the dots and figuring out a way of how you can use while loops and if statements and different types of variables to create a game or to create a product or to create absolutely anything. Okay? So are there any questions? Because I feel like I've been talking for too long and I feel like I've been giving too many examples today, so I'm going to give you a break and we're going to be talking more about while loops next time. But for now, if there are any questions that you'd like to ask about absolutely anything, please feel free to ask. Okay, awesome. So I do not want to introduce something new. And we've solved a good amount of questions today, but I'm going to be sending you some extra questions as well that you can solve and perhaps, and again, if you have any questions while solving the extra problems, please let me know. Other than that, you're good to go. And thank you so much, girls, for being here on time today. I absolutely appreciate it. So I'm going to stop recording.